Okay, so you've heard the buzz, right? Generative AI,
Yeah,
it seems like it's absolutely everywhere.
it really does. Creating stunning images,
Mhm.
writing code. It can feel almost, well, magical.
Exactly. But what is this technology, really? And, what does it actually mean for us, for business, for how we work?
Yeah, there's a lot of hype to cut through.
That's what we're going to do in this deep dive. We're aiming to unpack generative AI. We've gathered some really fascinating sources
Right, we've got research from places like Google and Stanford, some insights from Deloitte.
and analyses on its impact on creative work, the economy, all that stuff.
Hmm.
So our mission here is to give you a clear, solid understanding of generative AI, where it comes from, what it can do, some surprising things there, how it's being used now, and the big questions we need to think about.
Hopefully some aha moments along the way.
Let's hope so. Okay, to start, let's get on the same page. Artificial intelligence, AI. How should we think about that?
Well, AI is the really broad term, right? Systems that show intelligent behavior learning, reasoning, solving problems. The big umbrella.
Okay, the big umbrella. And under that.
You've got machine learning, ML, that's a key subfield. This is where algorithms learn from data. They make predictions without someone programming every single rule.
They learn it themselves from the data.
Exactly. And then diving deeper, there's deep learning, DL, that's a subset of machine learning.
Okay.
Deep learning uses these artificial neural networks. They're actually kind of inspired by the human brain.
Okay.
And they're really good at processing complex patterns in huge amounts of data. Doesn't matter if it's neatly labeled or just raw stuff.
So deep learning is the engine here.
Hmm.
But where does generative AI fit in? What makes it generative?
Right. So the key thing is, generative AI is a subset of deep learning. It uses these powerful neural networks,
Wow.
and it's really flexible in how it learns. It can use data that's clearly tagged or figure out patterns on its own or even a mix.
Okay, so it learns in different ways.
Yeah. And to really get generative AI, you need to know the difference between generative and discriminative models.
Discriminative, what's that?
Discriminative models are about classifying things, predicting labels. So
Yeah.
you train it to tell a dog picture from a cat picture, it discriminates between them.
So it's like looking at a finished dish and identifying the ingredients, telling you what's there.
Exactly. Perfect analogy. A generative model, though, it does something different. It generates new data.
New data.
Yeah, based on what it learned from existing data. So instead of just identifying a dog, it can create a brand new picture of a dog, one that never existed before.
Whoa.
That ability to create, that's why it's called generative. It's like inventing a completely new recipe, not just listing ingredients.
Okay, that makes sense. Creating something new. And this relies on foundation models you mentioned.
Right. Foundation models. These are massive, trained on unbelievably huge, diverse data sets, often like the whole internet.
The whole internet.
Like Google's Gemini or LaMDA, they learn the fundamental structures within all that data.
And then
they use that understanding to generate new stuff that looks and feels like the data they were trained on. They're the base layer for tons of specific applications.
So these foundation models are key. But what was the breakthrough that really made them so powerful, especially for language? I heard about something called the transformer.
Yes. The transformer architecture. That was a huge moment. It came out of Google back in 2017, that attention is all you need paper.
Right. I've heard of that paper title. What did it change?
Well, before transformers, models like RNNs processed things step by step, sequentially, like reading a sentence one word at a time.
Yeah.
Transformers use something called an attention mechanism. It lets the model look at the entire sentence or sequence all at once. It understands how every word relates to every other word, no matter where they are.
So it gets the whole context instantly, not just word by word.
Exactly. That's the attention part. And because it can look at everything simultaneously, it processes information in parallel, much faster to train and way better suited for modern chips like GPUs and TPUs. Ah, okay. Faster and more context aware.
Totally. It's become foundational. It's not just for language models. You see it in computer vision, reinforcement learning, audio, robotics, even chess playing.
Wow, it's really spread out. Okay, so that leads us to large language models, LLMs. These are built on transformers.
Many of the most powerful ones are, yes. LLMs are basically neural networks trained on just vast amounts of text.
And their main job is?
At its core, it's pretty simple conceptually. Predicting the next word in a sequence.
Just predicting the next word.
Sounds simple, but when you train it on enough data, it becomes an incredibly powerful pattern matching system.
Can you give an example?
Sure. If you give
Yeah,
it, I'm making a sandwich with peanut butter and
it's going to say jelly or maybe honey.
exactly. And the more data it sees, the better it gets. More nuanced, more coherent. That's why something like Gemini can give a detailed contextual answer if you ask it, the meaning of life is.
Right, it's learned all these patterns of how we talk and write about complex ideas. Precisely. So their key strength is generating responses that sound natural, that fit the context. You can use them for tons of things, writing poems, blog posts, code.
Translation, answering
Well,
questions.
all of that. Really versatile.
Okay, this is where it gets really interesting for me, though. It's not just about text anymore, is it? These multimodal
Oh,
models.
yeah, multimodal is exploding.
Yeah.
This is where AI combines different types of data.
Like what?
Well, language and images, for instance. Models like Pally can look at a picture and answer questions about it or write captions for it in like over 100 languages.
Wow.
Then you have text to image. You type a description and it generates a picture. Models like Imagen or Partey can create really photorealistic images just from text.
I've seen some of those. They're incredible. What about video?
Yep, text to video too. Imagen Video can make short, high-res clips like a happy elephant wearing a birthday hat walking under the sea. And others, like Funaki, can do longer, more story-like videos, like a teddy bear swimming in San Francisco. Then it dives underwater with fish. That kind of narrative generation.
That's amazing. It's creating entire scenes.
And audio as well. Audio LM can generate speech that sounds like a continuation of someone talking, keeping their voice.
And even music?
Yeah, coherent piano music, for example, without needing perfectly labeled training data, which is quite something.
That's wild. And beyond creative stuff.
Oh, yeah, critical for things like self-driving cars. Fusing sensor data, combining LiDAR, which sees in 3D points, with regular camera images, gives the car a much better understanding of what's around it, better decision.
Right, combining different senses, basically.
Yeah.
The breadth of these multimodal uses is just staggering. It feels like the lines between data types are really blurring.
They absolutely are. It's opening up possibilities we probably haven't even thought of yet.
Okay, so bringing this down to earth a bit, how is all this actually changing work, like creative jobs, business stuff?
It's having a huge impact, really shaking up content creation, marketing, software development, design, entertainment.
Can you give some concrete examples?
Sure. In marketing, there are tools like Jasper. It's built on GPT-3, and it lights blog posts, social media copy, emails.
So marketers are using this.
Yeah, VMware, for example, uses it to scale up their content strategy. It frees up their writers to do more high-level stuff, research, planning, strategy.
Okay, makes sense. What about coding?
Big impact there, too. Tools like GPT-3's Codex or Microsoft's Copilot work like a pair programmer.
Like having an AI assistant helping you code.
Exactly. Deloitte actually did a pilot study. 6 weeks, 55 developers. They found a 20% improvement in coding speed on relevant tasks.
20%. That's significant.
And interestingly, even for developers who hadn't used it before, these tools can also find bugs, fix them, even explain code in plain English.
That's useful. What about chatbots in customer service?
LLMs are making chatbots much smarter, better understanding, more context-aware. Think Facebook's BlenderBot or Google's LaMDA.
Right, more natural conversations.
And then there's knowledge management. Morgan Stanley is fine-tuning GPT-3 on all their financial advisor content.
Why?
So their advisors can quickly search vast amounts of internal knowledge and generate tailored summaries or content for specific clients. Find the right info faster.
Okay, those are some powerful applications across different fields. But you mentioned a Deloitte study on customer support agents that seemed to dig deeper into the impact on workers themselves.
Yes, that study is fascinating. They looked at over 5,000 agents using an AI assistant.
And what did they find? Productivity boost.
Yes, overall productivity issues resolved per hour went up by 14% on average, which is pretty good.
14%, yeah.
But here's the really striking part. The biggest gains by far were for the novice and low-skilled workers. They saw a 34% improvement.
34%.
Yeah.
Compared to just 14% overall.
Exactly. Experienced workers saw very little change.
Wow. So it helps new people catch up incredibly fast.
That seems to be the key insight. The AI acts like a knowledge transfer system. It captures the best practices, the sort of intuitive know-how of experienced workers, what they call tacit knowledge.
The stuff that's usually hard to write down or teach.
Precisely. The AI makes that tacit knowledge accessible to newer employees, helping them get better, faster. It helps them move down the experience curve.
That's huge. It's not just doing tasks, it's teaching.
It seems so. And it wasn't just about speed. The study also found it improved customer sentiment,
Happier customers.
apparently, and it increased employee retention, too. People were less likely to leave.
Interesting. Did the learning stick? Like if the AI went away?
Good question. They found evidence of durable learning. Agents who used the AI kept some of their productivity gains even during software outages, especially those who used it more and followed its suggestions more often.
So they actually learned from the AI. That's fascinating. Did they always follow the AI's advice?
No, actually, on average, agents only followed the AI recommendations about 35% of the time.
Only 35%. Why so low?
Well, maybe context or agent judgment. But interestingly, those who did follow the recommendations more often saw much bigger productivity gains, like 10% gain for the lowest adherence group versus 25% for the highest.
So trusting the AI paid off more, even if people didn't always do it.
It seems that way. And they also looked at the language agents used. They saw changes in communication style, especially for the lower skill workers, suggesting the AI influenced how they interacted.
Okay, that study really paints a picture of AI as a performance and learning accelerator, especially for less experienced people.
Yeah.
But this technology isn't perfect, right? There must be risks, challenges.
Oh, absolutely. It's powerful, but it comes with significant complexities and risks.
Like what? What are the big ones?
Well, one major issue is hallucinations.
Hallucinations, like the AI sees things.
Not quite. It means the AI generates stuff that sounds plausible but is completely wrong, inaccurate, or even made up. It might confidently cite sources that don't exist.
Why did they do that?
Because its goal is to generate plausible text based on patterns it learned. It's not necessarily trying to be factually true. It's a pattern generator, not a truth engine.
Okay, that's a crucial distinction. Plausible versus true.
Hmm.
What else?
Bias is a big one. These models learn from enormous data sets, often scraped from the internet
Uh-huh.
and the internet. Well, it contains biases, racial bias, gender bias, all sorts of societal biases. The models can absorb and replicate those biases in their outputs.
Garbage in, garbage out, amplified.
Kind of, yeah. Then there's intellectual property. If an AI generates an image or text, who owns it? What counts as original? It's trained on existing work, so it's derivative.
That sounds like a legal minefield.
It definitely will be. Think substantial work for intellectual property attorneys. Plagiarism, copyright infringement, these are real concerns, and the human user is generally still accountable.
Okay, what about privacy, security?
Big concerns, too, especially if companies train or run these models on their own sensitive data. Keeping that secure is vital.
And the elephant in the room, jobs.
Yes, job displacement is a potential risk for certain roles. Absolutely. That's a societal conversation we need to have.
So lots of challenges. But even with these advanced AIs, it sounds like humans are still very much needed. You said at the beginning and the end of the process.
Absolutely crucial for several reasons. First, prompts.
The instructions you give the AI.
Exactly. Crafting effective, creative prompts to get the desired output is a skill in itself. Prompt engineering is becoming a real job title. You often have to try multiple prompts, refine them.
It's not just typing one thing and getting perfection.
Warily.
Hmm.
Second, evaluation and editing. Everything the AI generates, text, images, code, video, needs careful human review.
Like that artist who won the competition.
Right. Jason Allen with Midjourney. He spent over 80 hours, made over 900 versions, tweaked prompts constantly, then used Photoshop and another AI tool for finishing touches.
Wow. So a huge amount of human effort and artistry still involved. It's a tool, not a replacement for the artist's intention.
Precisely. It's a collaboration, a new kind of workflow.
Yeah.
Humans also fine-tune these models. Fine-tune.
You take a big general model and train it a bit more on specific data for a particular task or domain. And you might only need, say, 100 examples to significantly improve its accuracy for that specific thing.
So you can specialize these general models quite easily.
Relatively easily, yeah.
Yeah.
And then there's this really fascinating thing called in-context learning.
In-context learning.
Yeah, it's wild. LLMs can learn a new task just from a few examples you give them in the prompt itself, without any retraining or updating the model's core parameters.
Wait, how does that work?
We're still figuring it out, but research suggests they might be simulating smaller models inside themselves, learning on the fly from the examples you provide right then and there. It's incredibly efficient learning.
That's mind-bending. Learning without actually being retrained.
It's a bit spooky, yeah. Unreasonably efficient learning, as some researchers call it.
Okay, so pulling all this together, where do you see the real value of generative AI heading? Is it all about chatbots like ChatGPT? Well, chatbots are popular and they showcase the tech. But I think the real long-term value isn't just in generalist tools, it's in applying this technology to niche domains and specific contexts.
Meaning,
Companies training models on their own specific data, their internal documents, their product specs, their customer service logs, creating highly specialized tools for their specific needs.
like the Morgan Stanley example, but maybe even more focused.
Exactly. Building powerful internal information retrieval or generation tools tailored to their business. This also helps get around some privacy issues with using external services.
So a future of more specialized, integrated AI assistants.
I think that's where a lot of the practical business value will be, augmenting humans in very specific, high-value ways within their workflows.
Okay. So we've covered a lot of ground. We've seen how generative AI works, from the basic building blocks to transformers and LLMs, how it's going multimodal.
How it's impacting work, boosting productivity, especially for novices, transferring that hard-to-get tacit knowledge.
But also the risks, hallucinations, bias, IP issues, and the absolute necessity of the human role in prompting, editing, and guiding these tools.
Right. It's an incredibly dynamic field, huge potential, but also really important challenges we need to navigate thoughtfully.
And understanding this stuff isn't just for the tech folks anymore, is it? It's about how information gets created, how we interact with it, how we can use these tools effectively and responsibly in our own lives and work.
Absolutely. It affects everyone.
So here's a final thought to leave you with. If generative AI can capture and transfer that tacit knowledge, the stuff usually learned through years of experience, how does that change how we think about expertise, about learning on the job?
That's a deep question. If AI can accelerate gaining those unarticulated skills,
What does that mean for traditional learning paths? And what new skills become most valuable in a world where AI can help us learn the unlearnable faster than ever before? Something to ponder.